We're going to start by proving one of them. Sine of 2 theta equals 2 sine theta cos theta. Split it right there. You can write this on top of page 653. Lots of space on 653. We want to prove that sine of 2 theta equals 2 sine theta cos theta. Now, normally, what I do when we have more time is I would let you try to prove this on your own for a minute or two, at which case everybody would be stuck and not know what to do. Okay? So just pretend 2 minutes have passed and you're stuck and don't know what to do. Then I would say the hint for this proof is you have to use mathematics that you learnt or already knew in kindergarten. So now, that's a long time ago already, isn't it? So go back to kindergarten. What math did you know in kindergarten? Counting. Good. Anything else? Well, I think you might have known a little bit more, but it's connected to counting. What else might you have known in kindergarten? Like what kind of addition? Like 1 plus 1 equals 2. Do you think you knew that in kindergarten? So in this proof, that's going to be important. We have a 2 theta here. How could I write that? Instead of writing 2 theta, I could write theta plus theta. And then this matches up with the formulas we had from yesterday. If theta is my alpha and theta is also my beta, then I could take this and write this as sine theta cos theta plus cos theta sine theta. Can you see that those are like terms? So you can use that kindergarten math again. One of those plus one of those would give you 2 of those. And we've got our proof. Now, you will not have to prove these. Why? Because they're on your formula sheet. All of these double angle identities are on your formula sheet. So you'd never be asked to prove that on a quiz or a test because it's on your formula sheet. You're allowed to just change sine 2 theta to 2 sine theta cos theta. There's 3 formulas for cos 2 theta. And all 3 of them will always work. But in every question that there's a cos 2 theta, one of the 3 will be faster. You just don't know which one. So that'll be something we'll look at that. And there's also a tan 2 theta. If you want to know why there's 3 for cos 2 theta, one of the ones for cos 2 theta is cos squared minus sine squared. Can you see that you could change the sine squared to 1 minus cos squared? And if you combine like terms, you would get 2 cos squared minus 1. Same thing here. If you substitute the cos squared for 1 minus sine squared, you would get another formula. So all 3 of those formulas for cos 2 theta are on your formula sheet. So when we go to example 1 here, in part A, first of all, reading this question, given angle theta is in standard position with its terminal arm in quadrant 4 and cos theta equals 2/5, comma, all that stuff before the comma, have you not seen a ton of questions that start that way already? What did we do every time we have a question that started that way? We drew it out, right? We're like, I know it's in quadrant 4. Draw a triangle back to the nearest x-axis, label my reference angle. And since cos is 2/5, I know this side is 2, this side is 5, and I'm getting really good at a squared plus b squared equals c squared. What would I get for the other side? Square root of 21. Perfect. So that part before the comma is the same in so many questions. That's why this triangle strategy is so important. Can you find out what quadrant it's in? Can you draw it? Can you label all the sides? And then you now know what sine of theta is, cos of theta, tan of theta, all of them. Okay? But we want to find sine of 2 theta. On this graph, this angle here is theta. There is no 2 theta on that picture at all. However, we just got a formula that says sine of 2 theta is 2 sine theta cos theta. And from this triangle, well, I already knew that cos of theta was 2/5, but from the triangle, I can also find out that sine of theta is negative root 21 over 5. Because it's in quadrant 4, sine is negative. Then sine of 2 theta will be 2 negative root 21 over 5. And 2 over 5, remember 2 is 2 over 1. How do you multiply fractions? Multiply your numerators, multiply your denominators, and we get a final answer. Now for part B, like I said before, with the cos 2 theta formula, all 3 formulas will work. But one is better than the other ones. In this example, this is the better one. You have to see if you can figure out why. Partially maybe because it's whole numbers, because its cos uses the 2/5. But you're on to something there. Can you see that that's the only formula that uses cosine for the cos 2 theta formulas? The other ones have a sine squared in them. Look at the question originally, and you notice the question told us what cos theta was. To get sine theta, we needed to figure something out. Every time you figure something out, there is a chance you make a mistake. How many of you have forgotten a negative sign this year at one time? Yeah, almost everybody? There's a chance you might forget that negative sign. So if you had a choice to use the information you were given, that would give you a better chance of not making a mistake. Now, we have the right value of sine theta there. It wouldn't be bad to use that value. It's correct. We would get the right answer. But if you have a choice, this is slightly better. And so now I know that cos of theta is 2/5. Cos squared of theta will be 2/5 squared minus 1. 2/5 times 2/5 is 4 out of 25. I'm going to change the minus 1 to 25 out of 25 so that I have a common denominator. 8 minus 25. Negative 17 over 25. Okay, questions that you can do to practice. Question number 9.